Okay, so let's talk about the second type of transformation, which is reflection. Reflection. So whenever you look in the mirror, you see your own reflection. In other words, you see someone identical to you looking back at you. And that's what reflection is, right? For every reflection, we have a mirror line and we have the image and the shape facing each other, right? The image is facing the original shape on the other side of the mirror line. So in this illustration here, we have two E's. This is my shape, right? Okay, this is my shape, and this is my image, right? The shape and the image, between them is a mirror line. This green line, this is a mirror line, right? So they are facing each other on either side of the mirror line. Note that they are the same distance from the mirror line. This part here is 2 squares from the mirror line, and this part here is 2 squares from the mirror line. That part there is 4 squares from the mirror line, and that part there is 4 squares from the mirror line. So that goes right through. So the shape and the image are the exact same distance from the mirror line, and they are facing each other across the mirror line. Now, as we have explained earlier on, whenever you have transformations, you have a shape, right? A transformation that I'm going to call T. Okay, let me just write trans. And then an image, right? You have to learn how to describe the transformation that maps shape onto image, right? To describe it appropriately, right? So whenever you study a shape and an image and realize that it's a reflection, there are two things that you have to mention in your description. You have to mention that it is a reflection. You also have to mention the equation of the mirror line. The equation of the mirror line. Now, if you've looked at lines before, you realize that the lines that we draw on the Cartesian plane, these lines have equations. So it's important that when you are identifying your mirror line, since it's a line, you write the equation of that line. So for example, I can have a mirror line which is x is equal to 2, or I can have a mirror line which is y is equal to 2x plus 1, or I can have a mirror line which is y is equal to 3, etc. Right? You write the equation of that mirror line. Only these two things. These are the only two things that you're required to write when you're describing a reflection. Now, let's look at a situation where the y-axis is the mirror line, right? So if with a triangle here, right, which is our shape, if it's reflected across the y-axis, this is the image that we would expect, right? An equal distance on the other side of the y-axis. So this is what we would expect. Now, for reflections across the y-axis, we have a matrix, right? This matrix is minus 1, 0, 0, 1, right? So this is a matrix for reflections across the y-axis, right? What is the purpose of this matrix here, right? We can use this matrix, right, to find the coordinates of the image given the coordinates of the original shape. What do we have to do? We multiply this matrix by the coordinates of that original shape. The answers we'll get will be the coordinates of the vertices of the image, right? We're not going to do that now, but you should just know for later use, right? The matrix multiplies, right? If necessary. It's not always necessary, right? The matrix multiplies these corners. Now, the matrix is not mentioned when you're describing. Remember, we said we're describing a reflection. You mentioned the reflection in the mirror line. You do not have to mention the matrix. You only have to mention the reflection in the mirror line. Even if the reflection is the the mirror line is the y-axis, and you know that there's a matrix that can be used to find the image, you don't have to mention the matrix unless you are specifically asked to do so. Now we can also have a situation where we have the x-axis as the mirror line, right? So now this shape is being reflected across the x-axis. If you have your shape and then you have your image on the other side of the x-axis. Now again, like our reflection across the y-axis, our reflection across the x-axis also has a matrix that can be used, right? The matrix is 1, 0, 0, minus 1. This is not to be confused with the minus 1, 0, 0, 1. So for the y-axis, the minus is at the top, and for the reflection across the x-axis, the minus is down here at the bottom, right? The matrix is not used in describing the reflection. It's used when you feel that you want to look for the coordinates of the image, right? You simply take the coordinates of the original shape, multiply them by the matrix, and you'll get the coordinates of the image. That is the purpose of that matrix, right? Now, you can have other lines that are not the x and y axis as your mirror lines, right? So, for example, here we have the line y is equal to x, and then we have the shape and the image, right, equidistant on either side of the mirror line. So this the distance of the shape from the mirror line is the same as the distance of the image from the mirror line. You can have another line, for example, the line y is equal to 2. This is also the mirror line in this case, right? You've got your shape and you've got your image on the other side there, right? You have your shape and the image. Remember, some of you may ask, how do you know this one is the shape? How do you know this one is the image? All that information is given in your questions. We're not going to focus on that. You just need to focus on knowing what the shape and image would look like if reflected across the mirror line, right? Right. So now let's go into an example. Triangle E has the vertices 2, 1, 4, 1, and 4, 3. Draw triangle E. So we're going to start off with this, just drawing triangle E. And our vertices are 2, 1, 4, 1, and 4, 3. So let's go for it. 2, 1. 2, 1 is here. We have 4, 1. 4, 1 is there. And then we have 4, 3. 4, 3 is there, right? So this is our triangle that we're going to get. And this triangle is E. We can label our triangle E. So that's done. Now, B part 1. Triangle E is mapped onto triangle X by a reflection across the y-axis. So draw triangle X. So triangle E is mapped onto triangle X by a reflection across the y-axis. The y-axis. So the y-axis is this one, right? So I want to draw a shape which is on this side, right? Reflected across the y-axis, right? So all I have to do is use my common sense, right? All points must have the same distance on either side, right? So if I look at this first point here, this point is 2 squares or 2 units from the mirror line. So its reflection must also be 1, 2 units on the other side, right? This one here is 4 units. 1, 2, 3, 4. So its reflection must also be 4 units on the other side. 1, 2, 3, 4. I mark that. Then this one here is 4 units on that side. 1, 2, 3, 4. So its reflection must be 4 units on the other side. 1, 2, 3, 4. So once that is done, you've got your image there, and that's going to be your triangle X. So that's how simple it is to reflect across the y-axis, right? And then part 2 is write down the matrix that represents this transformation. This transformation was a reflection across the y-axis, and we know our matrix for the reflection across the y-axis is -1, 0, 0, 1. So that was our part 1. That's our part 2. We've got full marks. Was satisfied. Okay, so now how does the matrix work? How does this matrix work? I gave you a bit of a theoretical understanding of how the matrix works, but now let's try and use it practically, right? let's say we had our triangle E. We take these vertices for triangle E, right? 2, 1, 4, 1, 4, 3, and I'm going to write them as columns, right? So let's say we have triangle E here. Here are the vertices, triangle E's vertices. 2, 1, 4, 1, 4, 3. I'll write them as columns. 2, 1, 4, 1, 4, 3, right? So now what I want is I want triangle X vertices, right? Since I'm told that it's a reflection across the y-axis, right? This is the matrix that represents reflection across the y-axis. We use this matrix to multiply these original points. So you'll have minus 1, 0, minus 1, 0, 0, 1, minus 1, 0, 0, 1, minus 1, 0, 0, 1. Okay? So we multiply this times that, this times that, this times that. But make sure you write your coordinates in column form, not in row form like what we did earlier on. So you realize that if you simplify this, on this side you get minus 2, 1, minus 4, 1, and minus 4, 3, right? I won't go into detail on how to multiply matrices. If you're not quite familiar with how to multiply matrices, you can watch the video series on the topic on matrices where we explain this in detail. But if you multiply this, right, matrix by the original coordinates, you get the coordinates of your image. And that's exactly what we got here, right? Minus 2, 1, that's what we got here. Minus 2, 1, right? Minus 4, 1, that's what we got here. Minus 4, 1, right? And lastly, minus 4, 3, that's what we got there. Minus 4, 3, and those are the coordinates, right? So I could have found this by my reasoning, or I could have used the matrix, whichever one makes me more confident. So here's another example. Triangle A has vertices at minus 2, 1, minus 2, 3, and minus 4, 3. Draw triangle A. So let's draw triangle A. Minus 2, 1, minus 2, 1 is our first corner. Minus 2, 3, minus 2, 3, and then minus 4, 3, minus 4, 3. So there we are. There's our triangle there. And what's the name of our triangle? Is triangle A. We've drawn our triangle A. Okay, so now draw the line y is equal to x. Draw the line y is equal to x. And if you haven't done lines, please go and watch the video series on lines, and you will learn all about lines. But what we know about these lines is if you're going to draw them, you need a table, right? So for the line y is equal to x, you need a table, right? A table of values. So all I need is 2 x values and 2 corresponding y values. We know that you can pick any 2 x values, so 0, 1. And then you'll know from your equation, when x is equal to 0, my equation says y is equal to x, so y will also be equal to 0. When x is equal to 1, here, my equation says y is equal to x, so y will also be equal to 1. So 0, 0, 1, 1. So if we mark those points here, the point 0, 0 is this one, and the point 1, 1 is that one. Okay, so that's how you mark those points. Once you've marked those points, you can now draw a line, straight line, which passes through those points with your ruler. So there's a straight line that passes through those points. That line is my line y is equal to x. If you think this is a difficult process, you can go and watch the video series on lines. So I'm just going to erase this so that I make space for my work to come. So triangle A is mapped onto triangle B by a reflection across the line y is equal to x. Draw triangle B. So triangle A is mapped onto triangle B by reflection across the line y is equal to x. So now our line of reflection, or our mirror line, is the line y is equal to x. Now for you to do this, right, you need possibly two things, right? You can use, you need, let me see if I have space here. You need a set square. You need a set square. Oh man, I'm failing to write set square. You need a set square, right? A set square is those little triangles in your mathematical set, and you need a set of compasses, right? Right, that little thing that you use to draw circles, right? So what you need to do, you need to place your set square on this line here, right? So if this is my line y is equal to x, you need to place your triangle like this, right? So that it sits like this, right? And this is the 90-degree angle. When you do this, you then use this to draw lines from all these corners of the original shape, right? I'm going to draw the lines in red. So you use your set square to draw lines from these corners, right? What's actually happening here is that every line that you're drawing is going to form 90 degrees with this mirror line. The line from there to there must form 90 degrees there, and the line from there to there must also form 90 degrees, right? So let me make space. And then what you do, you extend these lines to the other side, right? You extend these lines to the other side. You extend them to the other side, and you extend them to the other side, right? Straight as ever, right? And then you use your compass to measure these distances. I'm going to use gray. So I'm going to measure this distance from the here, from the mirror line to that point. I measure that distance, bring it this side, and mark it there, right? Same thing, come to this point, measure that distance, bring it this side, and mark it there, right? And then measure this distance here, bring it this side, and mark it there. So this is not the most accurate version I could have had, but it's reasonable. And then I can now join those three and get my image. So this is my triangle B, right? So let's run through the process, right? Let's run through the whole process again. The first step is to draw perpendiculars from all points to the mirror line. So perpendiculars are lines that are going to come and form an angle of 90 degrees with the mirror line. When you now draw those lines, you extend them, right? You produce them to the other side of the mirror line. And you simply measure the distances of these original points and take them the other side, right? Measure the distances of these original points and transfer them the other side of the mirror line. You mark them off, and then you draw your reflected image. So you need to practice this with your set squares and with your compasses, right? I'll probably do another video where I show you how I do it with the set squares and compasses, but this should be a fairly simple procedure. All you need to do is draw perpendiculars from all points to the mirror line, extend those perpendiculars, and then transfer the distances of the vertices from the mirror line to the other side. Then you should have your image drawn nicely. Okay, here's another one. Triangle J has vertices at 1, 1, 1, 3, and at 3, 1. Draw triangle J. So let's do that. 1, 1, 1, 3, and 3, 1. 1, 1, 1, 3, and 3, 1. There's our triangle J. Sure, we can move a little bit faster now. Then draw the line y is equal to 5 minus x. Again, you need a table of values. Y is equal to 5 minus x, right? So when you're drawing these lines, you have to have two x values and two y values. So pick a 0 and 4, when 0, 5, and then 4 there, 1, right? So if you're not too familiar with this stuff, like I said, watch the video series on lines where I teach that. So the first point is 0, 5, 0 and 5. I mark the point there. And then the second point is 4 and 1. 4 and 1. I mark the point there. Now I can draw my line going through those points. So it's going to be a straight line. So that's my line. Y is equal to 5 minus x, right? And now triangle J is mapped onto triangle K by a reflection in the line y is equal to 5 minus x. Draw triangle K. So we're reflecting again. Remember, what do we need to do? We need to construct perpendiculars from those corners towards the mirror line. So from this corner here, I draw a perpendicular line that's going to come and form 90 degrees with the mirror line. From this corner, I draw a perpendicular line that's going to come and form 90 degrees with the mirror line. From this corner, I draw a perpendicular line that's going to come and form 90 degrees with the mirror line. And what do? I extend these perpendiculars, right? I extend them to the other side, right? I extend them to the other side like that. Once I extend them to the other side, I then transfer these distances to the other side. So I can transfer this first distance to the other side, it will translate there. This first distance to the other side, it will come here. And this distance to the other side, it will come there. Once I do that, I can draw my image, right? This is my image. And then that image is our triangle K. So it should be a fairly simple process of reflecting across these lines.